Today we are going to discuss this question. So if you read the question, it says that the system is in equilibrium, right? So this is the keyword. Then you have to calculate the magnitude and direction of friction on mass M2, okay, on this block. So it is assumed that this rope is massless or the string is massless, okay. And if you see the picture, it also tells you that this block is bigger than this. So let us write that M2 is greater than M1. Okay, it's visible from the diagram. Now, since it says it's in equilibrium, so let us list down the forces acting on each one. Okay, so we know that on this block, since it's in uh, tension will act and M1G will act downward, tension will act upward, and on this block this tension will act like this. Now M2G will act in this direction perpendicular to the earth's surface. So let us draw it like this. This is M2G, but we have to resolve it. So if you resolve it, then it will turn out that this component and this component, so this one will be M2G sine theta, and this component will be M2G cos theta, right? And there is a normal force acting on it. Fine. Now it says that it's in equilibrium, right? So if this will not move, then this must be equal to this. So we can write that it that T is equal to M1G. This is our equation one. And for this not to move, T should be equal to M2G sine theta. Now, so it turns out that if these things are same, then it will be in equilibrium. So even if this is equal to this, or you can say in this case, if this is correct, then M1G will be equal to M2G sine theta, and this G get cancelled. So we are going to have a relation that for equilibrium sine theta should be equal to M1 by M2. So this is the case with the, so if you try to understand what this equation says, then let us say, just let us take a number. Let us say this is uh, 10, this is 20. So it turns out that this is 1 by 2. So theta should be equal to it. We all know that it is 30 degree, right? Sine 30 is half, right? Okay, now it turns out that in this condition, when this force is equal to this force, then you don't need friction. Okay, so when this is the case, then we don't need friction. So in this case, even so friction is zero in this case. Okay, let us say this is case one. Case two we are taking, like let us say M2G sine theta is greater than t, then what will happen? So if you see this, if m2g sine theta is greater than t, then the block will have tendency to slide in this direction, right? Right. So what will happen if this is more than this, then friction will be in this direction. Okay, friction will be in this direction. Now, so in case 2, we can write it down that friction is pointing in this direction. So for equilibrium, m2g sine theta will be equal to T plus F friction. So if you put the value, so friction will be equal to m2g sine theta minus T. T we all know that it is m1g, right? So this is the value of the friction if this is true, right? Now it also turns out what will happen, suppose if tension is more than m2g sine theta. Okay, so third case arises that tension is more than m2g sine theta. Now in this case what will happen, that in this case, just we are going to rub this part so that we don't confuse. So in this case we are saying that this tension is more than this, so it will have tendency to go up. So friction in this case will act in this direction. In case 3, right? So for case 3, what will happen? Uh, Tension will be equal to m2g sine theta plus f, right? So in this case, as it turns out, tension is m1g, so friction will be equal to T minus m2g sine theta, and that will be equal to m1g minus m2g sine theta. Now as you can see that there are 3 answers to it, right? So the block can be in equilibrium in case 1. In this case you don't need any friction. Okay, in case 2, you need friction, and in case 3 again you need friction. Okay, we have not given any numerical value to it, but what is more interesting, that when we say static friction is a self-adjusting force, right? Self-adjusting force. So in first case it is adjusting its value to 0, then in the second case it's pointing in upward direction, uphill, right? And in the third case it is pointing downhill, right? So here, from here again we can conclude that the friction is a self-adjusting force, right? It can be 0, it can be up, it can be down, it adjusts its value. So for the equilibrium of the system, you can see that the tension is always positive, or friction, if you see, then this term should be greater than this in this case, right? And so on. So this is up with the inclined plane and equilibrium. Okay, thank you, and I will see you in my next class.